Okay, so here we are back down in the workshop. I'm setting up to do an experiment or to do a demonstration of an alternator that I've hacked a little bit, taken apart, and it does some interesting things now. We'll begin by taking some measurements of some of the things that I've got hooked up here, one of which at the moment is the alternator itself, the chassis to the alternator. So if I hook in the ammeter, or the ohmmeter, sorry, to one side, which is the ground plane, this is the chassis cable directly bolted to the frame of the alternator, and this is the rectifier output. There's obviously no electrical connection to the output of the rectifier, but there is to the frame, if I can get a clean earth, there we go, to the frame of the alternator. This cable here comes from the rectifier, which we'll have a look at in a second. Now I don't want you to come in too close, I want you to just stay out so that people can see. Everyone knows what an alternator is. So there we have the alternator over here. Move slowly and smoothly. Out the back of the alternator, I've taken some cabling from the field windings. This is the one end of the field windings. This is the other end of the field windings here, and into a rectifier. Just a simple basic setup. The stator itself here, the two cables to the brushes on the stator. One side comes down to this little coil in the jar, which is connected on the other side to, in a moment, to ground. But the other side of this little coil is connected to the output of the rectifier, one side of the rectifier. The other side of the rectifier is not connected to anything. The ground plane goes to the other side of the stator. Remember, that's not electrically connected to anything. Now, the output from the rectifier goes up into this little jar here, which has two tubes in it, two stainless steel tubes, and we'll measure the resistance of those across there. Don't come in too close again, I'll say it again. People don't want to see right in close, they want to see what I'm measuring. So that's measuring nothing, no resistance, infinite resistance. There's no resistance that side, infinite resistance this side. So I've hooked the cable through that. Now, out the other side, we will attach a load. We'll also watch on the input shaft here of the drive for the ammeter, 1/3 horsepower motor, which I've connected an amp meter to, a clamp meter to the input wire so we can see the amperage load. We'll see it unloaded now. We'll power it up and we'll have a look at the ammeter. So it's drawing 6.4 or 6.3 amps without being loaded up. Nothing's turned on at the moment. Now if you watch over here, I've got down here a 12-volt battery to use as like a jump starter, and we'll power it up. There we go. Now you can hear the change. Have a look at the ammeter. It's now drawing 9.70 amps, 9.6 amps. So that's loaded up. Now, over here, we now have this output wire that I can connect to various points of the load. Remember, we've got this connection here to the chassis of the I'll go over the ammeter. Go over the ammeter again. What's that say? 9 ohms? 9 amps? Yep. And I'll disconnect the lights. And the ammeter goes up. I'll connect them again. The ammeter goes down. Now come back over here and we'll watch some interesting things going on over here. So that's two lamps. On this side we have a lamp that's a 12 volt lamp, both elements work. I can power either, sorry, I can power that. No? Oh, I can power that one there, and that lights up both. So that's connected through. Yeah, so powering, this is a little bit confusing to explain, but we have on this side the ground plane to the alternator. This is the load, and this is the power side. So by powering this one on this side, both light up. By powering this one this side, they also both light up. Powering this one, nothing lights up. Powering this one, nothing lights up. What did I do before? I put in I think. I can't remember. I moved something before. Yeah, there we go. So with that one there connected, nothing lights up. With that disconnected, they both light up. One a little dimmer than the other. This one's a 24 volt lamp. That's just the low beam lighting up. Oh, sorry. No, I don't know how to get this the low beam to light up. We'll do an ammeter current reading there. So I'll put that across amperage. And we got a reading. We got you can see the screen, can you? That's drawing 4 amps of current at voltage reading. We can do at a combined voltage of 19.4 volts AC and 9.8 volts DC. Looking at it on the scope, hang on, let me just get this hooked up to the microphone. Now we can do a scope trace, because I've got the oscilloscope turned on. So I'll go from there, across there. We'll look at the scope trace. That's hooking into the load between the two clips there. So we're on the 1 volt scale, 5 volt scale. So I'll go up to the 2 volt scale, turn up the readout, so 2 volt scale. We've gone up to 2.3 there, so times 2 is 4.6 and something just blew in there. See that fucking thing? Piece of shit fucking thing. Well, have a look at the ammeter again over there. The plant meter shows 8.9, 8.5 amps. And I'll disconnect the load again. Watch over here. Disconnect that. Now let's have a look at that. 8.8 amps. Why is it the same again? Oh, 8.5. Again, 8.6. So that's connected. That's disconnected. Alright. What else could we look at? Oh, we could look at the AC. Maybe. If I don't blow it up. So I'll go back into there. I'll go to AC coupling. It's not going to show me any sort of a wave at all. So it says there's no underlying line. So the scope shows no underlying ripple current at all. I don't know what popped before, but I didn't like the sound of it or the look of it. Oh, there we go. Coupling DC, coupling AC. It's not going to show any trace of AC signature at all. And yet it measures AC on the underlying. Alright, so that's it. Now just to prove that the battery isn't doing anything, we'll move it over here. So yeah, that's one wire powering through infinite resistance, 2 loads at 4 amps. I don't know what else to say. That'll do for now. I hope I haven't destroyed my oscilloscope.